Dr. Babasaheb Ambedkar, Morocco University, Chhatrapati Sambhajinagar, UGC, MLCTC, on 13th online faculty induction program. I, Dr. Subhash Shivajirao Patil, Assistant Professor and Head, Department of Mathematics, Venkateshwara Mahasan Senior College, Karachi, would like to give a seminar on the topic Matrix Introduction or Introduction to the Matrix. So, in this topic, we are going to see the different objectives related to the introduction of the matrix. So, the learning objective was to recall the definition of a matrix, understand the properties of matrices, discuss the type of matrices, to know what is meant by transpose of the matrix, then properties of matrix addition and matrix multiplication. These are the learning objectives. So, the introduction to a matrix. The matrix has a long history of application in solving linear equations. They were known as arrays until the 18th. The term matrix derived from the letter matter, or the meaning of that matter is mother, was coined by J. Lopez in 1850, who understood a matrix is an object giving rise to a number of determinants. Today we call it as a matrix. That is to say, determinants of smaller matrices that are derived from the original one by removing column and rows. These are the determinants. An English mathematician named Philip was the first to use modern bracket notation for matrices in 1930, and he simultaneously demonstrated the first significant use of notation capital A is equal to IG to represent a matrix where A of ij refers to the element found in ith row and jth column. The matrix can be used to completely write and work with multiple linear equations, referred to as the system of linear equations simultaneously. Matrix and matrix multiplication reveal their essential features when related to linear transformation, also known as linear math. Then we are having the actual meaning of the matrix. That is, what is meant by a matrix. So let us have the definition of the matrix. A matrix represents a collection of numbers arranged in an order of rows and columns. It is necessary to enclose the elements of a matrix in a parenthesis or any square bracket, round bracket, etc. So, simple word, a matrix is nothing but a representation of a number in the form of rows and columns, which are enclosed between the brackets. It may be either parenthesis, square bracket, round bracket, or parenthesis, etc. Then the matrix representation is here. A matrix with 9 elements is given here. That capital M is equal to, this is the parenthesis. So matrix is enclosed between the parenthesis. So it is enclosed between this green parenthesis and the elements of matrix are given. So 9 elements are there. So in the matrix we are having rows as well as columns. So there are 3 rows and 3 columns present in the matrix. So the first row, as we see here, 169 is the first row, 825 is the second row, and minus 107 is the third row of the matrix. Whereas we have the columns in the matrix. So first column is 18 minus 1, second column 620, and third column is 957. So this is nothing but the actual representation of the matrix. So this matrix M has we previously have the discussion with the 3 rows and 3 columns. So the matrix CM having 3 rows and 3 columns. So here we are having to see the position of the element. So for example, here we have A of 2, 3 is equal to 5. So A of 2, 3, it means that it is the element of second row and third column. A of 2, 3, second row or second element. Second row for it means this matrix CM has 3 rows and 3 columns. Each element of the matrix capital M can be referred to by its row and column number. So for example, here we are having the position of the element 5 and it is denoted by A of 2, 3. So that is the A of 2, 3 is second row and third column is the element head, and that is nothing but the 5. Okay. So here the A of 2, 3 is nothing but the element A with ith row and jth column. So this is the position of the element in the matrix. Then we are going to see order of the matrix. What is meant by order of the matrix? The order of the matrix is defined in terms of number of rows and number of columns present in the matrix. That is, order of the matrix is equal to number of rows into number of columns. Therefore, in the previous matrix capital M, we are having 3 rows and 3 columns. So the simple multiplication of rows and columns is nothing but the order of the matrix. So here, in the previous matrix capital M, 3 rows into 3 columns, that is nothing but the order of that matrix. Then next, we are going to see types of matrices. So there are so many different types of matrices. So first of all, we are going to have the discussion on square matrix. So what is meant by square matrix? Here, a square matrix has as many rows as it has a column, that is number of rows is equal to number of columns. In simple words, we say that a matrix having number of rows is equal to number of columns, then we call it as a square matrix. Then second, symmetric matrix. So after the square matrix, every matrix is a square matrix. So in the symmetric matrix, a square matrix is said to be symmetric if the transpose of original matrix is equal to its original matrix. So that is A of t is equal to A. So here A to the power t is nothing but the transpose. So A of t is equal to A, that is nothing but the symmetric matrix. Then skew symmetric. So what is meant by skew symmetric? A skew symmetric, or we call it as anti-symmetric or anti-matrix, is a matrix which is a square matrix whose transpose is equal to its rigidity. That is, A of t is equal to minus t. This is the skew symmetric matrix. That is, E of t is. Then diagonal matrix. So a diagonal matrix is a matrix in which the entries outside the main diagonal are all 0. Okay, the term used usually refers to square matrix. Then next, identity matrix. A square matrix in which all the elements of the principal diagonal are 1 and all other elements are 0. Then such a matrix we call as an identity matrix. So identity matrix is denoted as the capital letter R. In simple words, we call it as a unit matrix transpose. Okay. So the next is orthogonal matrix. A matrix is said to be orthogonal if this condition is satisfied and that is nothing but A into A transpose is equal to A transpose into A is equal to I, where I is the identity matrix. So if this condition is satisfied, then we say that it is the orthogonal matrix. Then idempotent matrix. A matrix is said to be idempotent if A square is equal to E. Means what? If we are having matrix A and we are multiplying that matrix again with the same matrix, so we will get the same matrix A, then it is the idempotent matrix. Then involuntary matrix. A matrix is said to be involuntary if A square is equal to I, as we know that I is the identity matrix. So keep a note that every square matrix can uniquely be expressed as sum of a symmetric matrix and skew symmetric matrix. Okay, and that is nothing but capital A is equal to 1 by 2 into in a bracket AP plus A plus 1 by 2 in a bracket A minus AP. Okay, that is nothing but a square matrix expressed as the sum of symmetric and skew symmetric matrix. These are some different examples for the order of the matrix. Either it may be 2 by 2, 3 by 3 or 4 by 4. So in the first question, if you want to write any square matrix of order 2, then it is nothing but capital A is equal to 3, 5, 4, 6. This we call the matrix of order 2. Then we are going to write any matrix of order 3 or order 3 by 3. Then the diagonal matrix of order 3 is given here. So capital A is equal to 2, 0, 0, 0, 3, 0, 0, 0, 6. So this is the matrix. We call it as a diagonal matrix. So 2, 3, 6 are the diagonal of the matrix, and other elements, non-diagonal elements are 0, and we call it as a diagonal matrix of order 3 by 3. Then next, if we want to write a matrix of order 4 by 4, then